Please welcome Dr. Tokede. He is currently associated with the International School. He is heading the school and senior lecturer in the School of Architecture and Built Environment at the Deakin University. He is a life cycle certified assessment professional over last 10 years of work experience with a strong commitment and track record in integrating life cycle sustainability thinking into building and infrastructure projects. He is the initiator and the research lead of Thinking Buildings at the Deakin University, where he undertakes industry-oriented and practice-focused research on applying life cycle thinking to projects. So, the floor is yours, and as 12 minutes plus 3 minutes is what we'll do the presentation.
Okay, good afternoon, everyone, and thank you for the opportunity to present to you. So I actually have really enjoyed the last two presentations, particularly from Professor Narada and Associate Professor Penelope. I think they're very interesting perspectives, and I really just think they kind of tie in nicely to some of the things which we're working on when it comes to waste to energy. So the first point I really want to try to make is that this particular presentation is quite an evolving study. So this is kind of, we just laying the groundwork for some of the things that will be happening going forward into the future. But I also believe that there will be a lot of opportunities to be able to respond to some of the issues which Penelope has raised and which Professor Anuradha has also raised as well. So just generally, I'll pretty much run through what I'm trying to do today, pretty much providing a bit of a background, which may be quite familiar, but maybe for those that may not be quite used to what's happening in this space, I'll give that introduction, and then I'll talk about some of the global overviews. Particularly, I'll talk about the sustainable transition pathway. So this is pretty much trying to make sure that as we think of transitioning into a much more renewable economy, what does that mean? There's going to be rebounds, there'll be shocks, but we kind of need to be able to have what I would call a roadmap. And what we're trying to do, particularly in this study, is to make sure that waste to energy has such a roadmap that does birth a sustainable future for us. So firstly, I just really want to put this background out that a lot of times we've had very, very mixed feeling when people talk about waste to energy. And that's because some people think that waste to energy actually disincentivizes recycling, okay? If you go to, for example, in Australia, we've got a Green Party, and the Green Party explicitly opposes waste to energy. They don't actually support it as a technology because they really don't think it is viable. But nonetheless, waste to energy is kind of a really, really important initiative when we think about that particular sustainable future that we're aspiring to. And when we're looking at waste to energy, ideally, we're trying to talk about how we can address those unrecyclable waste fractions. The other good point to make is also that many of us are quite familiar with this waste hierarchy, which we talked about. And if we look at the waste hierarchy, we can see that waste to energy is quite consistent with that same framework as well. So there isn't any reason why we should actually eliminate it, even whether the technology is limited in some capacity or not. Now, when we think about waste to energy, we're more or less thinking of how we can actually treat our waste such that we'll be able to lead to recovery of energy, and that actually means we produce some form of electricity, and that could help us to run our industrial or home processes. And a lot of times we've had a few concerns, particularly about waste to energy. Most of the concerns we have mostly comes to about carbon emission, which is starting to be what I'll call the tunnel vision of environmental impact, because as a life cycle assessment practitioner, we do have emissions that go beyond just carbon, although we feel that that is the narrative for today and possibly into the next 10 years. But very soon, we're going to be talking about human toxicity, we're going to be talking about land use, and all of those other 16 or 15 other indicators. So it is very important for us to think about it in that context. But also, a lot of people, like I mentioned, often are concerned that, if we're targeting 65% recycling, as we do have in many other climes, then, waste to energy is actually going to be a disincentive to that. And a lot of times we do have some solutions, obviously regulatory solutions, some of the things which Professor Anuradha talked about, but also we're looking at, social approval in communities, some of which we actually had in the keynote presentation earlier today about what is actually affecting, people who really don't really want any change because they've actually had these industries for the third to fourth generation. So what we actually did in this project was to basically try to look at waste to energy case studies around the world. We tried to actually map out what are the technologies that were being used, what has been the performance that have been done. And what we try to focus on particularly is looking at bioeconomy. So rather than looking at circular economy, which again is very popular and common, but we realized that bioeconomy provides a much more compelling case when we think about waste to energy. And so we tried to go through the literature, and then we try to map out what is happening quite around the world. So again, this actually comes up with we just playing around with what are the descriptions we can find. We looked at waste to energy. We looked at a couple of countries. We can see that very much so. It is very clear that Asia and Europe have actually been leading lights when we think about waste to energy. We can also see that there are many other parts of the world, such as South America and Africa, where we do have very, less uptake of waste to energy. And the other point to also mention is the reasons for this in different climes matter. Some of it is, due to cost, but also some of it is just part of the concern. And going on, I actually also just want to point out that it was interesting that although we tried as much as possible to go as far back as possible, we realized that when we talk about reasonable case studies, it was mainly from 2011 that we started to see a little bit of uptake in terms of people doing, some work. Obviously publications have been growing as well, and we can also see that across these various lines, we've actually had two main technologies. So these technologies are either going to be either biochemical processes or thermochemical processes, okay? Although we're starting to have much more what I call hybrid processes, but many of these things are still in its infancies. So because of that, we try to focus mostly on the thermal processes. Now, we try to more or less also go into what content analysis is. And I would say one of the drivers of this content analysis was to try as much as possible to look at what is actually happening. Like, for example, for waste to energy, do we really put them in urban context or do we put them in rural context? And we realized that more often than not, we'll probably find them in urban context, okay? And we find them in urban context simply because those are the places where we have, the waste. But obviously the rural context are more or less the places where we do have opportunities because we do have much more land there. We also try to look at what are the drivers. So drivers could actually be, do we really invest in this project because we want to get rid of waste, or do we actually try to invest in them because we're trying to, have some form of energy security? We realize more often than not that most countries tend to do a bit of both, which means that energy security, obviously a much bigger issue in developing countries than developed countries, but there's still a driver that we could always do with improving our energy performance. But then we started looking at a few other things as well, which was the fact that for most people, they actually see waste to energy as a bit of a transitory technology. So which means that, we want to make sure that in 30 years from now, for example, when we hit net zero, we should actually look at waste to energy as something that we get rid of because it's not going to be necessary any longer. But a lot of times we realize that most people do not really look at it that way. So if we look at the feasibilities, we can see that particularly for the temporality, most of it is also always between 11 to 30 years. We also looked at the environmental assessment, and again, there was the disproportionate emphasis when we think about global warming potentials, okay? So I'm going to talk through some of what this means. So what this led us to was to try to generate what I call a meta-narrative of what is going on. So what we find out, again, was that incineration and anaerobic digestion, they are the predominant processes which we often tend to use all around the world. Part of it is because of cost, part of it is also because of they are the ones that are the proven technologies which we have. We also looked at what are the top environmental impact are. Again, beyond global warming potential, which takes a large chunk, we do have a few other ones. We can see that majority of our economic metrics, again, some of us have talked about the financing issues. We can see that we face just payback period and net present value. And again, there's a bit of social consideration, but this is actually much less in the literature. So this is a little bit of a summary which you could see. So we try to actually look at what the greenhouse gas emission values is, and we can see that on average, we try to look at it on a continental basis. We can see that majority of the emissions we have from thermochemical processes are way higher than biochemical processes. We actually noticed that there was a bit of an outlier in what we saw in South America, but we think that this is just because we've got limited case studies at this point in time to be able to follow what is actually going on. So now, what this actually led us to was trying to make sure that we build a taxonomy, and this taxonomy is more or less around what do we think is going to happen, both at a project level moving on into the national level and then looking at the global narrative. And we saw that, we have some very, very high level global, I would say, documents that actually guide, the transition to, and many of them are the sustainable development goals, some of them the net zero targets. But if we start to go into the national level, we start to see what I would call a cluster of different economic, technological, political persuasions. And this is actually being driven because different countries have different waste streams. There are different capabilities, both technical and economical. But we also have a lot of different perception and different cause and effect mechanisms that drives waste in these countries. But at the project level, we're starting to look at, the location. We're looking at, the capacity of the plants. And what we're trying to do more or less is to try to be able to look at what will be a strong modeling pathway that can help us to be able to ensure that whenever we want to go, we can start to look for how this particular process should be run in a way that we can follow the trends, we can know what we're doing things right, we can know how to respond, particularly based on other technological advances as well. So this actually led to the development of this framework, which is more or less a major outcome. And so we try to look at the drivers, we look at some of the stakeholders that are involved, and we try to look at some of the impacts that we should be looking at. So you can see very clearly here that we looked at least 5 main drivers, which was trying as much as possible to implement some of the things we found from our content analysis. And what we've basically done with this is to make sure that this is actually incorporating stakeholders there, because if some of these stakeholders are actually not informed, I think that there's a problem that this process is going to be stalled regardless of the amount of environmental emissions that we can find. And obviously, particularly for the social issues, we're trying as much as possible to use life cycle thinking as a particular way to be able to help us to be able to map out what is going on. So what actually is then going forward on this is that we're basically in the process of developing a digital twin model for waste to energy plants. So we're trying as much as possible to look at a digital model. Again, while we're developing this digital model, is going to be addressing some of the issues that have been raised about the technology issues, whether it's about the compression that we're seeing, or whether it is the fact that we cannot segregate or aggregate our particular waste very well. So the digital tool will help us to be able to do that. And we're going to be doing the impact assessment, which means we're not just going to be looking at greenhouse gas emission alone, but we're going to be looking at greenhouse gas emission in the context of other environmental impact, as well as other, I would say, sustainability impacts, such as the economic performance, as well as social performance. And what we then do once we start to go forward is that this is going to help us to be able to develop the next iteration of what the sustainable transition pathway should be. And what the objective, or what we're trying to do and achieve in this process, is to make sure that as we go on and as we start to see us move into renewable world, a sustainable future, we can more or less have a bit of a roadmap that actually guides us to be able to see how best we can optimize decisions that go on into the future. So this is kind of where we are. This is the pathway that we're trying to do, and I'll be happy to answer any questions from anyone. Thank you very much.
Questions? I have a question.
Yes, please.
So can you go to the previous slide, please?
Okay. All right.
So
yes.
Here, so you are looking to simulate all this using computational model, all the phases.
Yes.
Yeah.
So particularly, each of those phases will require different, what I would call modeling expertise. So if you look particularly at phase 1, where we're more or less designing the plant, we'll pretty much focus on softwares like former, chemical engineering, thermodynamic software. So that's kind of what we're going to do. But then as we move into that, then we'll start to go into things like system dynamics, where we'll start to use any logic software to be able to see how that actually works together. But at the same time, we're trying to make sure that we get real live case study data that can help us to be able to simulate. So this is kind of the pathway we're planning to follow.
Yeah. I think, have you considered agent-based modeling?
Yes.
Yeah. I think agent-based modeling would work very well with this, particularly at phase 3, but I think it can work on all of this. But
yeah. So we're basically, that's why I mentioned any logic software, because any logic can do both agent-based and also system dynamics.
Yeah, I've done something similar. I can share you.
Yeah. I would love to see that. Thank you so much.
That's good. Any other questions?
Just a quick remark. The best thing you can do is not produce waste. Many of us my generation grew up in India, we ate on banana leaves, and anything that was left was fed to the cows, and there was no truck that came and picked up any garbage. There was no concept of garbage. So shouldn't we as a society go back to zero waste? All this plastic after is throwing them? What kind of behavior is that? Don't we have to move? And isn't that the number one thing we should be doing?
Well, I do agree, but I guess what I think is more likely and more feasible is that unfortunately we've moved past that generation. I mean, that doesn't mean, and I don't think necessarily within this context that we would achieve it. And I think the trend is also changing depending on the different countries. For example, the kind of waste that is being produced in developing countries is very different from the kind of waste that is produced in developed countries. So I feel there's going to be a change in the dynamic behaviors that we're going to continue to see. But I don't really think that if we follow that behavioral narrative alone, that we're going to be able to achieve a sustainable future. So I think we'll just work with what we have. And then as time goes on, if we see an improvement in behavior, we can actually continue to, just work in that journey. Because that would be my perception.
Actually, answering your question, we in our project we had a scenario, future scenario over the next 30 years, centralized versus decentralized, and one of the scenarios was what you just said, that produce less waste or produce no waste. So that worked very well in environmental terms, but economical wise was not a good idea. So in terms of economy, it's not great because a centralized big system is more economic.
You want the best economical answer, keep burning fossil. And enjoy.
Anyways, thank you very much.
Thank you very much.
I'd like to make a small announcement.
Before that, please. Yes. So this is a token of appreciation from the Energy Summit.